In this session, we'll review some of the options for managing energy data using an Energy Monitoring Hub and BMO software. First, let's look at the Energy Monitoring Hubs, or EMH. While the core functionality is essentially the same, the user interface has been updated with the new EMHXD and EMHSP, so we'll consider these two separately. Leviton has several models of data acquisition servers, each with a different feature set. The A7810 is the entry-level model, which only offers 4 pulse inputs and no Modbus RTU connection. The A8810 is the most popular model with a Modbus RTU connection but no pulse inputs. The A8812 comes in a ready-to-mount enclosure and offers both Modbus RTU and 8 pulse inputs. EMHXD and EMHSP are the newest models, which offer some significant enhancements. EMHXD features dual Ethernet and dual Modbus, providing double the capacity of RS-485 devices. EMHSP features dual Ethernet with a single Modbus and 4 analog inputs and 2 relay outputs. All models utilize a browser-based interface. They all capture and consolidate the meter data and can be set up to push that data in a variety of ways. Observe polarity throughout the entire RS-485 daisy chain run. No more than 2 sets of wires should be at any given termination point. Star configurations are not supported. The ModHoppers create a 900 MHz self-healing mesh network to create a wireless Modbus network. Each ModHopper relays communication so that the EMH sees the ModHopper RTU devices as if they are hardwired to it. At a high level, each string of RS-485 devices needs to tie to a ModHopper. Each ModHopper then needs to communicate wirelessly with at least one other ModHopper node. Having a strong wireless connection to more than one node is better. Each ModHopper has 2 pulse inputs that can be used to capture the input from the pulse meters. Here we have a more complex example of multiple different methods of data collection back to a single energy monitoring hub. This example builds on the previous one by including Ethernet-connected devices. While it is not a typical configuration, the EMH is capable of managing both Modbus RTU and Modbus TCP or BACnet devices simultaneously. Next, let's review the setup of the data collection portion of the system using the A7810, A8810, or A8812 EMH. First, confirm that all devices associated with the system are reporting and visible in the device list on the Energy Monitoring Hub. If there are devices missing, troubleshoot those devices to resolve any wiring or configuration issues. With all the devices reporting, validate that data is being collected and that the data is accurate. Configure the data logging and upload intervals to the end user's requirements. If ModHopper wireless transceivers are being used, ensure all ModHoppers are accounted for under Wireless ModHoppers. As a rule, a link quality of 30 or greater at each node is required for reliable operation. If the quality value is below 30, logging of metering data at that node may be intermittent and unacceptable. ModHoppers installed near lots of metal, thick concrete, or too close to other radios, including other ModHoppers, may result in poor signal quality. If possible, move the ModHopper to avoid any obstructions. Contact technical support for assistance in troubleshooting poor link quality. With RS-485 settings configured in the EMH to match that of the connected slave devices, navigate to the device list to populate it with all the connected devices. You can also use the manual add link instead of waiting for the auto-detect process to work. It can sometimes take several minutes to detect a device on the RS-485 daisy chain. Allow sufficient time after resolving a wiring or configuration issue at the slave device or when a new device is added. Devices can be automatically dropped by the EMH if left in the unconfigured state. It is important to make sure all devices are configured and showing status as OK. You should name the meters and data points from pulse meters using identifiers with site information that does not change. For example, room names or numbers, addresses, suite or apartment numbers, a panel name, or perhaps a specific device load name. While troubleshooting any device that's specifically in error, click on the device number and remain on that page. By remaining on that page, the Energy Monitoring Hub constantly attempts to pull that particular device for data. If the status switches between error and OK, it could indicate loose wiring or too short a timeout setting. If you have a constant error 139 and you fix any loose wiring, the status should update to OK on that page. At this point, all devices and any points within a device should be named. All devices should be showing status OK. If you have any devices in error, click on the device and find the error number and description so that you can further troubleshoot. Keep in mind that the status on the device list page is from the last time the EMH pulled that device. You should click into each device and confirm the live readings. If the meters are connected to a load which are active, you should see some energy accumulation on those metering points. If you do not see any accumulation on active loads, notify the electrician so they can troubleshoot. In new buildings with no active loads, you are relying on the electrician having installed CTs and voltage sense wiring associated correctly. When commissioning advanced meters that report power factor, you will want to see a power factor greater than 0.7. Assuming a minimal load, a low power factor indicates a potential meter wiring issue. If irregularities are found, an electrician can confirm voltage and CT sense associations with a multimeter and amp clamp. In this section, we'll review the data transmission settings in the system that allow the EMH to push data to external systems. There are two primary data transmission goals. 1. Configure the upload channels and frequency of data log uploads. 2. Test and confirm that all active data transmission paths are successfully uploading data. From the device's logging menu, you can select the data logging interval. The default of 15 minutes is typically the appropriate selection. Change this only if the customer specifically requests a different interval. This section shows the typical settings to send data to BMO 4.0. Set the scheduled upload time. Connect every 15 minutes. Set Upload Channel 1 protocol to Obvious Building Manger Online with SSL TLS security. Enter the upload URL, https://upload.levitonbmo.com/. Password. Set a unique password. Keep a record of the serial number and upload password for handoff to the end user. With all the settings entered, click the Apply button to save the configuration. After applying the upload configuration, the system will display a message at the bottom asking to run the connection test. Click on the link to execute the test. Verify connectivity to the BMO 4 server. Look specifically for the Success Channel 1 or other applicable channels. If you receive this message, then the EMH was able to speak to the BMO 4 servers. If any failures, you'll want to work with the local IT contact to make sure everything is set up correctly for using the internet connection. This may require changing some settings under Networking, Setup in the EMH. To initiate the initial synchronization with the BMO servers, force a data upload to BMO by clicking the Upload Data Now button in the lower right-hand corner of the screen. On the next upload, the first set of data will be made available in the BMO platform. If the customer intends to sign up for BMO service right away, it is best to force a second data upload immediately after the first forced upload. The customer can then create a BMO account and begin viewing the recorded data. In this segment, we'll review the data management settings using the new EMHXD or EMHSP energy monitoring hubs. Next, let's review the setup of the data collection portion of the EMHXD or EMHSP system. First, confirm all the devices associated with the system are reporting and visible in the device list on the Energy Monitoring Hub. If there are devices missing, troubleshoot those devices to resolve any wiring or configuration issues. With all the devices reporting, validate that data is being collected and that the data is accurate. Configure the data logging and upload intervals to the end user's requirements. Ensure all ModHoppers are accounted for under Wireless ModHoppers. As a rule, you'll want to see a link quality of 30 or greater at each node. If the quality value is below 30, logging of metering data at that node may be intermittent and unacceptable for the application. ModHoppers installed near lots of metal, thick concrete, or too close to other radios, including other ModHoppers, may experience poor signal quality. Whenever possible, move the ModHopper to avoid any obstructions. Contact technical support for assistance in troubleshooting poor link quality. With RS-485 settings configured in the EMH to match that of the connected slave devices, navigate to the device list to populate it with all the connected devices. The auto-detect process will identify many devices and add them to the device list. It can sometimes take several minutes to detect a device on the RS-485 daisy chain. This is true if you just resolved a wiring or configuration issue at the slave device, or if it was just wired in or powered up. Devices can be automatically dropped by the EMH if left in the unconfigured state. It is important to make sure all devices are configured and showing status as OK. Use the Rename Devices option to name meters and other devices. While troubleshooting any device that is specifically in error, click on the device and remain on that page. By remaining on that page, the Energy Monitoring Hub constantly attempts to pull that particular device for data. If the status switches between error and OK, it could indicate loose wiring or too short a timeout setting. If you have a constant error 139 and you fix any loose wiring, the status should update to OK on the page. If you're unsure of how to troubleshoot a particular error, contact technical support and they can help assist you. At this point, all devices and any points within a device should be named. All devices should be showing status OK. If any devices display an error, click on the device and find the error number and description to further troubleshoot. Keep in mind that the status on this device list page is from the last time the EMH pulled that device. In this section, we'll look at the system's data transmission settings that allow the EMH to send data to external systems. There are two primary data transmission goals. 1. Configure the upload channels and frequency of data log updates. 2. Test and confirm that all active data transmission paths are successfully uploading data. From the Data Logging Rate menu, you can select the data logging interval. The default of 15 minutes is typically the appropriate selection. Change this only if the customer specifically requests a different interval. From the Uploads Upload Schedule menu, you can schedule the preferred upload time. There are other settings available on this screen, but it's generally safe to use the default settings for these. Each of these have a pop-up window describing what they do. This section shows the typical settings to send data to Leviton's Building Manger Online. Set the scheduled upload time. Connect every 15 minutes. Set Upload Channel 1 protocol to Obvious Building Manger Online with SSL TLS security. Enter the upload URL https://upload.levitonbmo.com/. Password. Set a unique password. Keep a record of the serial number and upload password for handoff to the end user. With all the settings entered, click the Apply button to save the configuration. After applying the BMO upload configuration, the system will display a message at the bottom asking to run the connection test. Click on the link to execute the test. Click on the Begin Test button to initiate the connection test for the assigned upload channels. Verify connectivity to the BMO4 server. Look specifically for the Success Channel 1 or any other applicable channels. If you receive this message, then the EMH was able to speak to the BMO4 servers. If any failures, you'll want to work with the local IT contact to make sure everything is set up correctly for using the internet connection. This may require changing some settings under Networking, Setup in the EMH. Back on the Uploads Upload Schedule menu, click on the Upload Data Now button. This will initiate the initial synchronization of the BMO servers to force a data upload. Data will be made available in the BMO platform after the second data upload has completed. If the customer intends to activate BMO service right away, it is best to force a second data upload immediately to make their data available in BMO. The customer can then create a BMO account and begin viewing the recorded data. The data upload status should change, indicating it's working on uploading the data. It will continue to update on status until it's complete. Completion will be indicated by displaying the next upload date time. In addition to the BMO upload option, the EMH provides the other data transfer options. Data may be stored in the device onboard memory. Data may be sent to another user-specified URL. Data may be uploaded to an FTP server. Data may be transferred to an XML file format. Acting as a gateway, the EMH may provide access to data directly to another device. Leviton's energy monitoring hubs provide an option for users to download their log data directly from the EMH using the integrated browser user interface. Log on to the EMH as usual. From the navigation menu, select the log file data section, and under that, log file export. This will open the log file export window. Use the drop-down selectors to select a device, the file format used for the download. In most cases, the comma-delimited CSV format is appropriate. Normally, the default double quotes option is selected. If for some reason headers are not needed on the data column, checking the No Column Headers box removes them from the export file. With all the selections made, click on the Download button to execute the file transfer. Because each download is for a specific device, you will need to initiate a separate download for each one you wish to download data for. For each device, simply select the new device and click the Download button. This is an example of the CSV file export. This file represents the data from a Series 7000 virtual meter. Each column represents the data values for each parameter, and they are grouped together by a virtual meter element from left to right. Each row represents the interval data with the timestamp for each set of records in column A. While the monitored data may vary from device to device, this basic data file layout is followed for each device. Now we'll take a quick look at Leviton's Building Manger Online software solution. One of the first questions often asked is software really necessary? Software is a tool, but it's not required with Leviton's EMH products. As we just illustrated, the data is available for download directly from the EMH and can be made available to a variety of other analytics tools and systems. While software is not mandatory, it can streamline the data management and reporting needs, particularly in large systems. With smaller systems, utilizing the direct data download with some simple spreadsheets may be sufficient. With the Verify submetering systems, software is a nice-to-have feature. Many of our competitors do not have a viable way to read their meters without using their software. Because we utilize open protocol formats, our EMH products are compatible with a variety of industry standards and can be integrated with building automation systems using BACnet logging, third-party tenant billing providers, and a variety of other data management and analytics platforms. Who needs Building Manger Online energy management software? Tenant billing is an important application for BMO software. It is used by property owners and managers needing to generate utility bills for their tenants. These can be residential or commercial properties. All BMO accounts are licensed by metering point count in blocks of 50 data points per license. For tenant billing, this is typically just the consumption or kWh values, which is one data point per tenant. Another important and growing need for energy management software is to meet energy code compliance requirements. The common theme with ASHRAE 90.1, IECC, and most other regional energy codes is their requirement for disaggregation of load types. They require building owners to monitor and report their electrical consumption in total, as well as in categories like HVAC, interior lighting, exterior lighting, receptacle loads, and in some areas, process loads may be included. In order to capture and total all lighting loads in a building, multiple metered loads must be added together or aggregated to provide a total lighting load figure for the building. This is typically accomplished by the metering system or software using virtual metering functions. Virtual meters are values derived from the sum of multiple meters added together or subtracted from one another. While some form of energy code has been adopted in most jurisdictions across the country, the specifics vary from area to area. Codes are constantly changing and newer versions being adopted in different areas. This map illustrates some of the variations of the codes adopted from state to state and why it's important to keep up with the changes in codes adopted in the markets you serve. To meet code intent, meter data must be captured in specified intervals and stored for at least 36 months. Graphical displays of data are required if the building has a digital control system installed. Not all digital control platforms are suited for this type of functionality. The system designer should consider plans for a separate AMR platform with local or cloud storage and a graphical presentation capability. Leviton's system architecture was made for this type of project. Our hardware solutions are flexible and adaptive with a variety of different devices for data acquisition using pulse inputs, Modbus, and wireless. Open protocols make sharing data very easy. With the defined interval data recording, it is easy to meet the code requirements for reporting. Our data acquisition platform is built for ease of data capture and reporting. BMO is a next-generation web-based software-as-a-service platform with multiple modules for purpose-specific applications. The Basic Energy Visualization module provides a variety of dashboarding and basic reporting tools to meet most requirements. The Tenant Billing module is for those needing to generate tenant invoices from their consumption data. The Advanced Enterprise module provides extended custom report design tools as well as the kiosk display option, which runs independently from its own URL. The system is hosted on Amazon Web Services platform for scalability and reliability. All BMO accounts are subscription-based with annual renewal fees based on the total number of active data points, not meters. The BMO Base Module provides several user-selectable formats for viewing the system data. There are options for displaying data in graph formats using line graphs, area graphs, and bar graphs. Data cards with up to 4 individual data points are also available. Any of these views also provide a tabular view of the underlying detailed data, which is easily exported as a CSV or spreadsheet file. Using the virtual meter functionality enables users to easily comply with the code compliance load type aggregation reporting. BMO is a subscription-based software platform with annual renewal fees. While there are no limits to the number of buildings or properties on an account, all accounts are based on the number of active data points. Licenses are sold in blocks of 50 data points per license. The system will also accommodate as many users as needed to manage an account. In many cases, nothing more than a simple consumption report is required. The consumption report is a quick and easy way to provide a simple cost accounting report. This same data can be used to develop a code compliance reporting structure. The Advanced Reporting module adds to the core functionality by adding some additional advanced reporting features. There is a customer report writing tool which enables the users to design their own custom report formats. The kiosk display option provides a nice scrolling screen display of selected values, which runs independently from the rest of the BMO reporting tools. Logging into the kiosk from its own URL makes this an ideal solution for code requirements for a public display of the energy data. It can run on a separate PC browser interface, on a monitor in a lobby, or other public areas. The Advanced Reporting module also features several additional pre-configured reports, which can be very helpful for energy managers to identify anomalies or problems in a facility. The heat maps and after-hours reports provide useful insights into when and where energy is being used. The BMO dashboards are user-configured tiles with either graphs or data card presentations of the data. The system is based on an integrated mapping system which will geographically locate the facilities on a local area map. BMO is compatible with a variety of types of utilities, including electric, gas, water, and steam. Metrics from any of the system monitors can be presented on the dashboards. The drift analysis report compares data points over time periods to help spot changes. It compares one period to another like period. The data is graphed as well as shown in a table below the graph. As with most of the reporting tools, this data is easily exported to a CSV or spreadsheet. The daily and hourly heat maps show the consumption in color-coded timelines, making it easy to spot the peaks in consumption over time. Being able to see when and where the peaks occurred can help an energy manager spot potential saving opportunities or system problems. The Facility Tree Map reporting is another reporting tool to help energy managers identify which areas of their facilities are consuming the most. This is another way to graphically present the overall facility consumption and highlight potential areas of concern. The after-hours report is an easy way to determine if lights and HVAC systems are being left on when a facility is unoccupied. Again, this report graphs the data over time and provides a table of the raw data. The report is easily filtered for specific timeframes and can be a great tool for managing multi-tenant buildings. This is a closer look at the kiosk display. It is primarily used as a public display option to promote building efficiency. It consists of a user-defined list of cards which rotate continuously across the screen. The data is generally based on the selected 15-minute interval data, and it can be pulled from individual data points, virtual meter points, or any other available system data. The following is a quick review of the core features and how they are configured to fulfill the core code compliant requirements. This is a preview of the typical home screen dashboard options in BMO. It illustrates the various graphical display options using either graphs or numerical data cards to present the data. The colors for each item are user selected, so there can be a wide range of color options to match any color palette. Graphs may be done using line, bar, and area graphs, which may be combined with up to 4 data points on a single data card. Individual metrics may be shown in individual cards, such as total energy summaries for the day, week, month, or year. Up to 4 of these related metrics may also be combined into a single data card, such as total HVAC summaries for day, week, month, year, including multiple data points. Hovering over the data in any of the graphs will highlight the underlying data for that point in time. Clicking on the button in the upper right-hand corner of each data card will open a new window showing the data in a table format. Exporting the data in the table is as easy as clicking on the CSV or Excel links in the upper left-hand corner of the window. This is an easy way to generate report data from any of the data cards on the dashboard. This is the resulting Excel spreadsheet with all the data from the data card download. It is a simple report with all of the timestamp data, which can then be used in other third-party analytics tools. Click on the Matrix menu option at the top left-hand corner to open the Apps menu. This shows the available embedded apps and reporting tools for the current user license. Click on the Consumption Report icon to open the report window. The consumption report is a primary need for the vast majority of users. This standard report allows users to quickly generate a complete summary of the consumption data required for code compliance. From the Report menu, select the properties to be included, fill in the date range for the report, and if the report is to calculate a cost, fill in the value per unit, kWh. Click on the Generate button to execute the report. The resulting report will be displayed showing all of the active data points included for the selected properties. If a unit value was entered, it will also show the total dollar amount for each data point. As with the other reports and data cards, exporting the data is as easy as clicking on the CSV or Excel links in the upper left-hand corner of the report window. For users desiring a live display option for their data, the kiosk option provides a scrolling set of summary data tiles. This reporting option is only included with the Advanced Reporting Module upgrade. It has a separate URL which allows it to run independently from the rest of the BMO, allowing this kiosk view to run on a separate PC and be displayed in the lobby or other public areas in a facility. In summary, the base module BMO software is sufficient for the majority of applications. It meets the core code compliance requirements for graphical presentation and reporting by load type, and it meets the 36-month data storage requirement. By creating dashboard metrics with the core reporting data, the export feature can be used to easily generate reports. The pre-configured consumption report may be the only report many users need. The Advanced Reporting module offers some additional reporting tools and a custom report writing engine. This may be an excellent option for the energy manager looking for tools to make their job easier. The Tenant Billing module provides users wanting to manage their own tenant billing with a convenient way to generate invoices. This platform works well for residential, commercial, or mixed-use billing applications. This was a quick overview of Leviton's Verify Energy Data Management Solutions. Thank you for your interest and consideration. For more information, visit leviton.com/verify.